We're going to continue with geometric sequences today and look at another real-life example. In this example, a certain type of bacteria cell splits into 2 bacteria cells every hour. Suppose the culture begins with 3 bacteria cells. And make a chart to start off with. At the beginning, at hour 0, there are 3. Each of those 3 splits into 2, which means now there's a total of 6. Then those 6 each split into 2, giving us 12. The 12 split into 2, which is 24. And if we look at what's happening here, what we're doing is we're multiplying by 2 every hour. That's the recursive rule. If we were to draw a graph of this relationship, we would have the number of hours on the x-axis and the number of bacteria on the y-axis. And my graph is a little large, but what you can see is that as the graph goes on, as the number of hours go on, the graph gets steeper and steeper till we get to those 96 bacteria in hour 5. We could write an explicit rule for this sequence. The 0 term is how many bacteria we had at 0 hours, which was 3. The ratio was what we were multiplying by, which was 2. So if you remember from yesterday, the way you write the explicit rule for a geometric sequence is the 0 term times the common ratio, and that common ratio has to be raised to the n power. So here, my 0 term is 3, my common ratio is 2, and my exponent is n. What we're going to do today is use this explicit formula to make predictions of what will happen after a longer period of time or further down the sequence. So if we want to find the number of bacteria cells after 7 hours, that is our n of 7. So I'm going to take my formula, 3 times 2, and I'm going to plug 7 in the place of n. In order to do this, you're going to need a calculator. My suggestion is to go to Google and type in calculator to get this screen. Some of these values will give you really large numbers, and they can be a little difficult to do on the phone calculators. You can type everything in one step on this calculator. 3, then I'm going to put the 2 in parentheses. The exponent is here where it says x to the y power. I hit that button, and my exponent is 7. And now it looks like what my formula did. If I hit equals, we get a pretty large number here of 384. Now, let's think about what would happen another 7 hours later, after 14 hours total. I'm going to plug into the formula, but plug 14 in the place of the n. Back to my calculator. 3 times 2 raised to the 14th power, I get 49,152. What you're going to find with these geometric sequences is that because you're multiplying by the same number, they will grow very quickly, and you will get very large answers for your numbers, or very small numbers in some cases. So we're going to do mostly what we did yesterday, but then add another step to the problems. Here, I go 4, 32, 256, and so on. And so I'm looking, this is a geometric sequence, I'm looking for the common ratio. Take a number and divide it by the one before it. Take 256 and divide it by 32. Each of these is 8. That's my constant ratio. The 0 term is what would come before this. So going forward, you multiply by 8. Going backward, we have to divide by 8. 4 divided by 8 is 1/2 or 0.5. You can put in either way. Our explicit formula is the 0 term times the constant ratio to the n power. We did all of that yesterday. Today, we're going to find one of the later terms. We're going to take, in this case, the 11th term, 0.5 times 8 to the 11th power. I'm going to go to my calculator. I'm going to do 0.5 times 8 to the 11th power. And you're going to get some very large numbers for these answers. So in this case, we get a number that is over 4. We get a number that is over 4 billion. The answer in this case, and we're multiplying by 8 11 times. That's why this is so big. It's 4,294,967,296. One more example. Here, we see these numbers going down. If you take a value and divide it by the one before it, 40 divided by 80 is 1/2. And again, you can use 1/2 or 0.5. Whenever these numbers are going down, the number you multiply by is going to be less than 1. This constant ratio is 1/2. Multiplying by 1/2 is the same as dividing by 2. So going this way, we're dividing by 2. Working backwards, we would multiply by 2 to get the 0 term. My explicit formula is the 0 term times the constant ratio to the n power. Then I want to find the 8th term. I go to my calculator. I type in 160 times, and I can either do 1/2 as a fraction, 1 divided by 2, or you could type in 0.5 raised to the 8th power. And in this case, because the numbers are going down, I get a small number, 0.625. For today's homework, you are only doing half of the problems. I'm giving you the whole worksheet. If you want more practice, you can do more of them, but you are only required to do the ones that are in the assignment.